So today I'm going to talk about two important features of Kotlin. One is data classes, another one is field classes. Those are a bit higher level concepts as compared to what the classes that we have in Java, and both of these features allow us to write very elegant and concise code. So let's look at the code. So let's look at an example of a data class. So data class user, and then so what we have done here is we have declared a class which is user. It has three properties. All three properties are read-only properties. The first one is first name, second is last name, and third is the age. We can also turn them as mutable properties by changing a val to a var. So these are all public properties right now, but we can also change them to private also by adding a private modifier. So in this case, the first name would not be visible outside of the user. So, and this also is the primary constructor of the user. Let's try to create an instance of user. So if you see now, we have to pass all three parameters, and then we get a new instance of a user type. And if we don't pass any, like suppose we're not passing the last name, we would get an error, a compilation error, saying that the last name does not match because it's trying to match the second parameter which is here, right? Or like let's say that we didn't pass the third one. Now it'll complain about that age is not present, right? So we say no value passed for parameter age. So and we could also add default values, right? Like default value could be 30 here. In that case, we can avoid passing. So this is just like we can add default values for methods. Same way we can add default values for data classes also. So here we can see like how concise it is to declare a class which is very similar to a Pojo class in Java, right? So in Kotlin, since all the properties we access them with getters and setters, right? So when we say user1.age, whenever we're accessing them, they're always accessed through getters and setters. So Kotlin generates default getters and setters for us for all of these properties. Other good thing about data classes is Kotlin also generates couple of other methods. So it also generates like equals method. So we create two variables, and if we try to print whether a variable one like user1 dot equals user2. So if we were working with Java, we would have to implement the equals method to make sure it is considering the first name and last name, and it is not considering like the address, right? Which is the default implementation. So let's try to run it and then see. Clear it first. So we see that the result came as true, right? Also, this is like by default, Kotlin would use the equals operator. So that's why it asks us to just use a double equal operator, which would by default call the equals method. Other nice thing is that we can print user1 and Kotlin, like the default implementation, provides a nice way of representing the properties. So here user has first name and last name, right? So whatever properties we added, those are printed nicely. So and similarly, like hash code is also added by default. It's also added to the data classes. Other very nice method that's added is copy. So we can just say user1 dot copy, and then like suppose we want to just overwrite the last name, right? So we could just say last name is dev, right? And then we can assign it to user3. And when we print user3 here, we will see that it's gonna have the last name as dev. Yeah, so the last name is dev now. So you can see like how our code becomes very concise, especially whenever like in these days we work with a lot of data transfer objects. Those could be either commands or events. So we don't need to write hundreds of lines of code just to declare a few properties. So very concise, and the code becomes very elegant now. So that is all about data classes. Let's look into the next feature, which is sealed classes. So sealed classes are very useful whenever we have a fixed hierarchy, right? So let's take an example here. Suppose we have a sealed class as a result, and now result can be just of two types, right? Or maybe like, let's assume maybe it's of three types, right? So class failure, and then we can say it as success, and other could be timeout. So a result could be just of one of these three types, right? So whenever we have any of these fixed hierarchies, sealed classes helps us. So let's see how it helps us. So let us add some properties to each of these classes, which will help us understand the problem better. So whenever we have a client code that is accessing, that is getting a result out, right, that has to work with any of the sub properties. So let's take an example. We have a main, right? We have a function. We declare also a function. Just something. Success. In that case, we would return. Let's say in this case, right? So first of all, some of the issues that we see here is, suppose like whenever we do anything, we call any of the methods which return a result, and we want to further process it, this code would be duplicate, right? All of these if-else conditions would be duplicate for all the methods that return a type of result, because we'll always have to see what type of a result is it, right? Whether it's a success or a failure or anything like that. Second issue which we see is, we see that there are only three type of possible subclasses, right, or possible results, but the if-else condition still forces us to, so like suppose in this case, I know the third one was timeout, but I have to either typecast it to timeout, right, which is not an elegant code to typecast it, right? Or other is, as we see here, we have to write if. Kotlin is smart, because it says that result is timeout, so it knows that there's a message, but still we have to write if else, and then we have to write an unexpected like result. But if we see here, there is never a condition that will have this. And also, whenever we're writing all of these if else and all, this is a source of bugs for a lot of problems, right? Because it is very likely that we'll miss like maybe one of the if else condition and all. And here it's still easy to handle when we have just three types of results. Suppose we are dealing with a class hierarchy which has like 7 or 8 type of uh, different results and all, right? Or different outcomes. In those cases, it is very easy to miss one of the if conditions. So what Kotlin does is Kotlin allows us to write a sealed class. And whenever we are implementing like or extending from a sealed class, we have to add the classes in the same file. So it's not that we can write a new file for success and extend from the sealed class. So we write a sealed class, we write all the classes that extend from the sealed class, right? So now we can see the useful feature of it is like, suppose I get a result, right? So now if we have to do the same thing here, so now when we see here, we just wrote two conditions. We handled the success and a failure, but we never added a condition for timeout, right? So our checks are not exhaustive, means they don't cover all the conditions. So Kotlin compiler is smart in this case because it says that when expression must be exhaustive, right? So we can also do this when result is like timeout. In this case, we can say it's message. So and this could be removed. Like if we add a result here, and we remove this result from here. So now Kotlin doesn't complain because when condition is specific to the result, which is the sealed class, right? Which corresponds to the sealed class that we return. So now Kotlin is smart enough to figure out that okay, there are just 3 combinations, and all the 3 combinations are handled. So it doesn't point out that we need a else condition which we had here. So this helps us in catching a lot of bugs, and this is a very useful feature, and probably like one of the very like most commonly used features of Kotlin.